Hello, College Biology. We used last year's mutation tutorial video, so that it left some things out, but there's some other things that I'd like to add. So we're using last year's mutation tutorial video, but this year's review notes video. So let's begin. Mutations are changes in the nitrogenous base sequence of DNA. The following are the top 3 causes of mutation. 1. Accidents during DNA replication for cell division. They occur at a rate of approximately 55 mutations among our 3 billion base pairs per generation in humans. So 55 differences between you and your parents, in addition to whatever shuffling you got between them. And then radiation is our second most common cause. If the radiant energy is greater than the activation energy or energy of dissociation for that DNA, it will cause the DNA to change. And examples of radiation that does that include UV rays, X-rays, and microwaves. But melanin is a pigment protein created by humans that absorbs radiation and shields DNA from radiation damage. Different humans make different amounts of melanin. Mutagens are chemicals that react with DNA. Examples of mutagens include smoke and tar and char and nicotine and alcohol and any biologically reactive chemicals such as acid, bases, or cleaning solutions. So things that can damage bodies can damage DNA, and there are some things that are particular. Consequences of mutations on proteins. There's several. Silent mutations are the most common, which either occur in non-coding regions or they do occur in genes but result in the same amino acid, so no proteins are affected. Alternatively, there are missense mutations, which occur when one amino acid is swapped for another, and this causes the protein to change how it folds. Nonsense mutations cause an early stop codon, resulting in an entirely different protein. It's much shorter and it's going to fold differently. Frameshift mutations alter all of the codons after the mutation, and these include insertion mutations, where bases are added to the gene and change a bunch of codons, deletion mutations, where bases are removed from the gene, changing a bunch of codons. But either way, they both result in a different protein than before. If a start codon is mutated, then translation does not occur, so the protein is not made. If a stop codon is mutated, translation will not be completed and no protein will be made. And then if mutations build up in the non-coding region, new genes can result in new proteins. So what are the consequences of those mutations on the organism? Well, most commonly nothing, because silent mutations are the most common. 2. The second most common are loss of function mutations, where there is a loss of a trait, developmental or abnormality, or death. This is most common because if a protein changes its shape, it can't do its job. If its job is important, that will affect the organism. If its job is not important, well, then the organism just continues without that job. And then third, most common, are new proteins that have no effect. They simply waste energy to make. So there's some transcription for a new gene that makes a protein that doesn't do anything, so it's just there, and that can be a problem because you're spending amino acids and energy to make that protein. And finally, I say the most common, I should say the least common. The least common is that new proteins are made that do function, which either alter an existing trait or grant a new trait, and those are very rare. So this is our mutation review. I hope this helps. Struggle well.